best.
Yeah, that's yeah.
Hands-on.
Mm-hmm. Yeah, that's just amazing to me that they wouldn't take advantage of something like that because it's I mean, you look at the careers in aviation and you know there are guys that are getting, hey Kellen, how you doing? They're getting six-figure salaries for.
Me, my bosses are who can support an aviation classes. The careers are. What do you mean the careers are?
Oh my gosh! Yeah. Yeah, exactly. They have their focus. Yeah, it's a problem, and that is something that we hope to deal with. You know, at some point we're going to start producing materials for guidance counselors, career counselors, so that they know that aviation is a viable alternative. You know, if they don't want to go to college, maybe they want to get into the maintenance side of things. And you don't even have to go to a college to get your maintenance, your A&P. You could do it at a local airport. And again, their starting salaries are in the six figures. We had one, I think I told you, one student that graduated one of our classes years back, and he was offered a $120,000 a year job at just 6 months into his schooling.
That'd be nice.
Yeah, I know. Wouldn't that be great? I know we went into the wrong area. So, I should have gone to the airlines. I've got all my airline buddies are making like $320,000. And
Josh, I would get your guys' ass. I would half the year.
Yeah. Yeah.
I'll be on call.
Yeah, that's exactly what I hear too. They have duty cycles that they can't exceed. There's a certain, the FAA has requirements on that, but then the airline also imposes certain restrictions on it. So they can only work so much. The hardest part, I think, for the airline pilots is just all the red tape of training and staying current. They have to do a lot of that, which is all right. We're starting to get more and more pilots, United pilots, coming out to use our sim, since it makes it easier for them when they actually go to their main sim. They're all ready to take any, if there's any kind of test that they have to take or current training, they're just ready to dive into it.
Yeah, I just had 3 of my students graduate from the Navy. One just graduated from girl down there.
Really?
So, they're
that's fantastic. Yeah. Yeah, if you have any success stories of your students, going on to aviation, definitely pass them on to us, because that's stuff we'd like to share with other teachers, so that they're aware that these, you can get young people involved in aviation. They just learn so much about the everything that's in aviation. It just makes it so much easier for them. So, perfect. In a few minutes here, So, I wonder how you guys doing today. Good. Yeah, that automotion's that's pretty huge. Yeah. What's that? Oh, is that right? Oh my gosh. Morning. Yeah, that's I've heard them up and down the strip yesterday. There were a bunch of cars coming into town. A lot more trucks. Oh yeah. That's I see a lot of the. I guess there's some guys that have like the old cars that are kind of upset at that. So they like they want it to be like an old antique car show. What's that?
I think it was Caprice. It used to be virtually dog.
Was that? Yeah. Mm-hmm. Yeah. I know that they were concerned about it, but it's been a lot of I'm sure a lot of money for the the community. There's so much activity there. There's so much stuff going on. What's it? What is that? What is it again?
Hotels are crashing.
Oh yes, yeah. I'm sure they're all packed. So. It's busy. So, hey Casey, Olivia, how you guys doing? Oh, you can move those magazines if you want. I can actually put them on there for you so you don't have to. And by the way, you guys, I'm gonna throw these out if somebody takes them. So if you guys wanna take a stack of magazines, I'll just put them right up here. A ton of aviation magazines, technical journals and stuff like that for aviation that's in there. What's that? It was bad. I had baseball size hail on my nose. It was pretty intense. So, all right, we got a few more minutes here. We'll see if anybody else shows up here. So this is going to be our last lesson. It doesn't mean that you're off the hook. If you want to get your, go on to take the test, there's still a lot of studying that you have to do. You want to go through the portal definitely and answer all the questions. I'll be available. If you guys want to get a hold of me, I can sit down with you individually and we can do training like on, weight and balance and stuff like that. I think weight and balance was, that was a kind of a tough one for everybody. And it is for most student pilots, understanding weight and balance. The one thing that I will say about weight and balance is, always, so just, there are formulas that I give you in the classes, and you want to write those down or remember those formulas, because you're going to have to know those when you take the test. So for instance, let's see here, the weight and balance formula that we all should remember is W-A, just wham. Does anybody know what that means? Right. Yep. Weight times arm equals moment. Okay. So what is the weight? Weight could be the weight of you, the pilot, right? It could be the weight of the gas. It could be whatever. And then the arm is what? Yep. How far it is from the datum point, not the center of gravity. It's an important point. So the datum point is, if you've got a plane, let's say here's our plane right here. Oops, there's our cockpit there. So the datum point on some planes might be here, and they would tell you this in the problems that you have. It may also be right here. So the pilot, in this case, if I'm the pilot right there, sitting down, whatever, I may be 70 inches aft of the datum in this particular aircraft. They're going to give you that information. They're going to tell you where the data point is. You have to figure out the weight and balance based on that. And it's just basically a table. So you're going to have the fuel load, fuel maybe one, pilot, passenger, luggage, and then you would write down the weights of each of those things right there. So it may be 200 pounds of fuel. Pilot weighs 160 pounds. And then the co-pilot weighs, let's say, 130 pounds. And then you're going to have your arm, which is, again, all your distances, and typically in inches is what they're going to report them in. And then you take all the moments there. You multiply this times the arm. So if the fuel is, let's say, 70 inches, you multiply that 200 pounds by 70, you get your moment, which would be 14,000, right? 14,000. That's our moment right there. And again, for a pilot, again, if the arm for the pilot, again, you're going to know that because they're going to give you that information. Maybe that's 50 inches. And that moment is going to be 100 times 50 or 160 times 50, which would be 8,000, right? Correct me if I'm wrong in my math here, by the way. The passenger, 130 pounds, whatever. So you'd go through it, and what you're going to do to find out your center of gravity then is add up all of your moments. So let's say our moments total, 20,000 or something like that. And our total weights equal, you're going to have a basic empty weight of the aircraft, which maybe, let's say it's 2,000 pounds. So you're going to start out with that. And then you're going to add up all the other weights here. So let's say we get, anybody good with math here? What is that total there? 220, 230, 230. 2,360. 460. So again, obviously check your math when you do this for real. So that's our total weight and our total moment. To get the center of gravity, it's really simple. It's just we do some basic math here. So we actually the arm is equal to the moment divided by the weight. And that's going to equal your center of gravity right there. So again, that's how you do it. You don't add up the arms here. That's a mistake that a lot of students make. They'll add up the arms and they'll try to do the math for that. It won't work. Whenever you're calculating the center of gravity for the whole aircraft, you always add up all your weights here, and you add up all your moments, and then you to figure out your arm, which is distance from the data, right? That's going to be, the total moments right here divided by the total weights, and that's going to give you your center of gravity. Does that make sense for everybody? Okay. So it doesn't make a difference if you're, the one thing you want to start out with the WHAM formula is definitely write this down. WHAM. Write it on a sheet of paper, and then start putting in the numbers. So on the test questions that you have in the learning portal, they give you tables for the weights and arms for all the different positions and their pilot weights and stuff like that. So you have to use that from the testing supplement that's in the first part of the session, or the very first session in the links or the SIA learning portal there. So you want to grab all your figures and stuff like that when you're doing quizzes, and you probably already know that, but there's in the very first session it has that information in there. So okay.
So could you use the same data right here to calculate the center of gravity?
Yeah, you certainly could. Yeah, you'd have to use some datum, and if they give you a datum point, you could use that, or you could just arbitrarily, you could just say that the datum is going to be the front of the truck, and then go from there. So yeah, it works for anything, whether you're trying to balance a plane or a teeter-totter or whatever. So today we're going to get back into navigation a little bit more, and then we'll kind of touch on aeromedical factors, although I think a lot of that stuff you guys can just read through when it comes to aeromedical factors. There's not a lot of stuff there that I can enhance in the material. With the navigation, though, there is a lot of stuff that I should kind of expand on. So we may focus most of the day on navigation. So one of the things that we talked about last week was we actually plotted out a course on our sectionals. You don't have to get yours out right now, but I think there was some confusion, some questions on using the first off figuring the distance. So let's actually walk through this whole process together, how you're going to do this. So the first thing you want to do, obviously, and you don't have to do it now, but you'd open up your sectional to wherever your two airports are at, right? What you're going to do is obviously you have to know your departure point and your destination. You want to draw a line between those 2 points. Now, here's an important point. When you draw the line, make sure it crosses a line of latitude or a line of longitude. You have to have something like that in there. You have to have, if it's a real short trip, like these two airports. Oh, let me just bring it up on the screen here. So let's say we've got, we're going from here, this airport right here, to this airport. Well, there's no lines of latitude or longitude through there. What you want to do is just extend your line through there. So you would actually draw a line from here, and you'd extend it through the nearest line of latitude or longitude. You can do it for as long as you want. You just have to know that the line that you're calculating is from here to here, okay? And then you're going to use your plotter, okay? The first thing you're going to do is look at your plotter and make sure that you're on the proper scale, because on one side, the blue side, on these particular plotters, I've got here, on the plotters that you guys had from here anyway, there's a blue side and a black side. So some plotters, they're just black on both sides, but you're going to look at the plotter, and at the bottom center of it, you're going to see, it's going to say either WAC scale, or if you turn it over, it's going to say sectional scale. Make sure you use sectional, okay? That the FAA actually has answers in there for the WAC scale. So if you do it with the WAC numbers, you're going to actually get what you think looks like an accurate answer, but it's wrong. So when you calculate the distance, you want to use the sectional scale on there. So the other thing you're going to do then is you're going to place your plotter over your course line and get the distance, and you're going to write that down. Okay. So if I've got, if I'm going from, this, you can't see it very well, but if there's an airport right here to here, what I'm going to do is place my plotter over that. And first off, make sure that I'm on sectional scale. I am. Okay. And then I'm going to put my, I'm going to read my statute or my nautical miles. We typically do all these, all of our flight planning in nautical units as opposed to statute miles there. So you place it on there, and this right here is telling me that it's about 26, 26 and a half. 26 is close enough, 26 miles, nautical miles on there. So I've got that, I write that down. And then the next thing you need to do, and this is critical, you need to figure out what the true course is. Does anybody know the difference between true course and magnetic course?
True course.
Next to the model, so everybody can read it.
On true course, you use true north, magnetic course, use magnetic.
Correct. So we have to do that because the lines of longitude and latitude are based on true north. They're not on magnetic north. And we couldn't, sectionals couldn't be done in magnetic north. I mean, they could do them in magnetic north, but they'd be printing them out every single week because the magnetic north is constantly shifting. So with true, we know that this is, if I fly this flight this year, 10 years from now, I'm going to have the exact same calculations for it. Whereas magnetic north, for using that, now it might be a totally different number. It shifts a lot. So it's moving, upwards of like 40 miles a year. That magnetic pole is shifting. So we have to rely on latitude and longitude. And that was, back in the seafaring days, they had to use something that was accurate so they could get you to your destination. It wasn't so much of a problem of being super precise, like today I can take this mouse, put it on a field and give you coordinates, and you could actually find it out there in the airport. That's how precise our navigation is today. But back in the old days, they were just worried about navigating to the other side of the planet. How do you get to that place accurately? So they couldn't use magnetic because it wasn't consistent. So they came up with this latitude and longitude. They needed to have something that was fairly accurate and would be consistent over time. And that's why we have Greenwich, mean time, Greenwich, England for the prime meridian. We have to have that. So in any case, you want to figure out what your true course is. Now, this is the part I want you to remember, because this is going to be, again, this is a source of confusion for all students, not just you guys. So if you're calculating a course that goes east and west, what you want to do is find out, first off, where it's this little area right here is kind of covering up the oops, just get there. This is, let's see, just get this situated here. Okay, so you can see this right here is the line of longitude right here. Latitude, I'm sorry, latitude runs east-west. There's the line of longitude. So when you're calculating a course that goes mostly east or west, you're going to use, you're going to place the little tiny dot in the center of your plotter. It's right there. There's a little hole in there. Look, you can take a look at your plotters if you've got them. There's a little tiny hole in there. That right there is going to be placed right on the course line and the intersection with the longitude line. Okay, very important. You do not want to place the ruler above that or below it. That dot should be at that intersection of the course line that you drew and a line of longitude, not latitude. Okay, not latitude. I see some students who will use the latitude line as a reference. You don't want to do that with that. Now, the problem is, what if your flight is north and south? So let's let me get this, clear this out. So here's a good example. This one is, it's going from, let's say we're going from this airport to this airport right here. Well, in that case, there's no lines of longitude that cross it. I mean, I could just extend this line until we hit a line of longitude, of course, but in this case, what you're going to do is you're going to use the inner arc right here. So this is the outer arc, and that's what we use. So actually, let me back up here. So again, we've got our course line. Let's do this again here. Just so again, I'm going to draw my course line. It's actually, oops. So draw from here to here and get it so it extends past that line of longitude right there. Okay. So again, we're going from this airport right here to this airport right here. Can everybody see this all right? Back in here, you see that? Okay. So again, what I'm going to do here is place my plotter with the hole right over this point right here, this line of longitude, okay? And then the plotter line is going to be in line with the course line that I drew there, okay? And what you're going to do is you're going to read your true course on the top part of the scale, this up here, okay? So you do. So in this case, I don't really have this right here with me. Actually, I do. Let me just see if I can get this. So in real life, if I'm calculating this right, so I've got my course line drawn. I put my dot over the course line and put it right over where that course line intersects with a line of longitude, and I get about 100 for going from here to here. I'm getting about 128 degrees true, of course. Okay. And you can try this out if you want. The thing that you need to remember there when you do that is obviously you have to use a dose of common sense, because when you look at your plotter, you're going to see two sets of numbers. You're going to see one on top, one, like in that case, that one says, it's around 120, 130. Let me just get that right. So, yeah, it's about, that's a real short trip there. So yeah, it's about 128, somewhere around in there. But there's two numbers. There's 130 that's close to that. If you look on your plotter, right here on your plotter, you're going to see on your sectional side, that is, you'll see 130 and 310. Well, obviously those are reciprocals, right? So if I add 180 to 130, we get 310. That's 180 degree opposite. It's just the reciprocal, 130 degrees. So that you have to use a dose of common sense. Well, which direction are you going in? Are we going to the southwest? And remember we talked about your compass rose, how that works. You've got 360 that's straight up, that points to true north. 90 degrees points to what heading? East. Yeah, that's going to be east, and then 270 degrees is going to point to west, right? Okay. So by having that there, you'll understand that you'll use a little bit of common sense. In aviation, a lot of times we use common sense just to make sure we've got the right result. Whenever you answer your questions on the exam, always again review it and just take a totally different approach and just say, does that make sense? When you answer the question, as opposed to doing a methodical method of doing it. Sometimes we just have to use a little common sense just to back up our thing. We're going to use it a lot when we do get into E6B here shortly. Okay, so does everybody understand that? So again, the critical point there is you put that center point on the plotter at the intersection of the line of longitude. If you're measuring east and west, okay? If you're measuring north to south, now you use the line of latitude. And you read the scale, not on the outer scale right here, not on this outer scale. You're going to use this inner scale for that, okay? Don't make the mistake of using this, because you'll get some really bizarre number. And it's going to be so far off, you'll know that it's wrong. Again, that's where you use a little bit of common sense there. So let's get back to our one that we had up here. So so we've got this flight that we're doing from here to here. So in this case, we can see we're crossing a line of latitude right there. If this was within the lines of latitude, all I would do is extend this line a little bit further, so that, we wouldn't, we could actually cross a line of latitude. And then what we're going to do, again, we're going to put our plotter here with the dot, that center opening right there, right on the line of longitude right there. Okay. And let me see if I can actually draw the plotter on here. So it's going to look, the plotter is going to look something like, let's see if I can do this. I'm going to try to attempt to draw a plotter on here, so it's going to be pretty bad, but let's see here. So the plotter is going to look something like this. Right here you have that little hump there, and then you've got the ruler there. And oops, the ruler is going to go like this. And that little dot, and I didn't do that quite right, the dot that's in the center there, that should actually be over this intersection right there. Let me just clear that off and do it again here. So I'm going to do this again. So there's the hump right there, and then the dot should be. So your plotter should look like this, with the little opening, the little hole in the plotter should be right over that point right there. Okay, and then here's our ruler on the plotter. Okay. And that's how you're going to do it. And you're going to measure not the outer scale. You're not going to use the outer scale. You're going to use that inner scale, that small inner scale that's right here. That's this one right here. Okay. That's the scale we want to use. And again, make sure you're using this sectional chart side for measurements there. And then this will read our distance. Like in this case, if I were to actually measure that, let me just do this here real quick. So I put my dot at the intersection of the flight, the course, the path there, and I've got it. And I've got two numbers here, 340 and 160. Which one do you think that would be? It would be 340 degrees. If we're going from north to south, which course would we use? What's that? 160. Yeah. Mm-hmm. Yeah. Mm-hmm. Okay. Why? That's why. Okay, well, think about what direction is 350 here on the map is, so first off, true north is up here, right? That's 360 degrees or 360 right there, right? Okay, we're south on this. Straight down, it's opposite, 180 degrees opposite. So that's 180 degrees right there. Where's east? To the right of the okay, yep, so there's 90 degrees right there. 90. Okay, and then 270 obviously is going to be opposite 180 degrees of 90. We add 180 degrees onto 90, we get 270. Okay, and we're going from this point right here to I can't move it, it's down here someplace. That's our location there. So up here, this, if I were to go in this direction from that airport, that would put us basically, that we'd be going about roughly, 340 degrees for our heading. We don't want to go north. We want to go south to this other airport down here. Okay, so I'm going to read, in that case, 160 degrees. Does that make sense for everybody? Does everybody understand that? Okay, because again, this is a real critical. I see a lot of students get these wrong on tests and practical tests and stuff like that. It's just all you have to do is just make one mistake on this, using it, positioning it wrong, or maybe not positioning it precisely on the course line, and you're going to have invalid results. So if you stumble, you will have navigation problems that you'll have to do on the test, on your written test. And in real life, your flight instructor is going to sit down with you and they're going to go over all this stuff again. But I want to make sure you guys understand this before you take your written test, to make sure that you have a good concept of how that works. Okay. All right. Enough of that. Let's talk about wind effects. So we're actually, let's go here. Okay. So obviously wind is going to affect our flight path, right? If we don't correct for it. So if I have a point, let's say on our, let's say we're going from point A up here to point B. Okay, what would, just anybody want to hazard a guess what that course line would be? Yeah, it'd be 90 degrees. Yeah, because we're going east, due east right here. And again, that's assuming that north is up. So let's put that in there so we've got it. All right. So on a no wind day, that would be perfect. We just take off and go. How often have we gone outside where we've seen no wind? It does happen, right? But that's just on the ground, right? In the air, there's almost always wind. You get up at higher altitudes and guaranteed you're going to have winds of 50 knots or higher. Maybe 100 knots when you get up to like 30,000 feet. There's some areas where there's a lot of wind. So we have to plan for it. So so here's our plane. Let me just draw this out here so you can see this. This is our plane right here. So it's the heading. This is the true heading is going to be 90 degrees. Okay, not our magnetic heading, because our magnetic heading is going to change. We have to solve for that as well. So 90 degrees, our plane's going this direction. No wind. Now, what if we introduce some wind here? Let's say we've got, let's say our plane travels at 100 knots. Let's write that down here, 100 knots. TS. All right, and let's say there is a 10 knot wind coming from the north, right? So the winds on the METAR, it would say, 360 at 10 knots. That's what it looked like, 360 at 10, or 000 at 10. I think they actually use 360 and not 000 there. So 360 degrees at 10 knots. That indicates to us a wind direction from the north at 10 knots. So 10 knots. So what are we going to have to do with this aircraft to make sure that it gets to this point B right here when we're flying? What do we have to do to it to make sure? Let's back up a second. What happens when you cross a river? If you've got a river right here, let's say, okay, you've got a canoe on this side. I'm going to try to draw a canoe, but I'm not really good at this, as you guys can tell. So there's our canoe. And the river is flowing down that way. Do I just point my canoe to this little place right here I get across the river? No. What do I have to do? Put it upstream. Yeah. So the canoe actually now points, if I want to get across, I'm going to have to point it like this. The path of the canoe is going to be like this, but it'll take us to that point. If there was no current there, yeah, this would work. That's what we're doing right here. We're flying from point A to point B with no wind. But now we introduce a wind, which again happens all the time. We've got wind, even though on the ground the winds may be totally still. We've got the wind, blowing from some direction here. So in this case, we're doing it really easy. It's just a 90 degree, 10 knot crosswind here. So we have to figure out what our corrected course, our wind correction angle is. That's the angle that the aircraft points into the wind, basically. And then we also then have to figure out our new corrected, course for the aircraft. So or our new corrected heading, I should say, for the aircraft, because we're gonna know it's gonna be a certain number of degrees up into the wind, so we avoid getting blown off course. That's what this diagram is showing us right there. So let's clear that all off. So, and this is in your books, I think, figure 16, 14 there. So 1610, okay, yeah, your books there. So here you can see the airspeed effect. After 1 hour, we've traveled a certain number of miles, or nautical miles there. And then you've got this, 20 knot wind out of your left, in this case from the north. It's pushing you off course. So if you didn't make a correction here, this is where the aircraft would be in 1 hour. It'd be 20 nautical miles off of course. If it's a 20 knot wind there after 1 hour. Okay, so we have to correct for that. And here's another diagram. You've got your heading that you're flying in the aircraft. it may be a true heading or whatever. At some point, you're going to you translate all this stuff into compass heading, because that's what we have in the aircraft. We don't have reference to true heading. Well, of course, unless you're using GPS, then you'll have that. So here, you've got this drift angle right there. So we've got to compensate for that. We've got to adjust the aircraft so that it's pointing in the proper direction, so that it avoids the winds here. So they do talk about these wind angles. If you want to study this, you certainly can. You don't have to, because you've got your neat E6B computer, and everything that you need to solve those wind correction problems it's right on the wind side. This is the wind side of the computer right here. This is your calculator side right here. It's where you calculate time. So the wind side, and it should make sure you can actually pull this little card out. If you look on one side of it, so I think on some of those plotters they have text on it, but the one that has, I don't know what yours look like. They're all different. Oh yeah, yours only has the black on this one side and the grid on the on this side, and then on the other side it's just a bunch of memory aids and stuff like that there. So you only have this side of the on your E6B. You want to make sure though that the computer, the wind side is showing that. You want to make sure that the wind side is showing that grid there. Okay, it should look like this with the curves, so you can see how they're going up there. So we're going to start with this. Now take a look at the top. Does everybody have their E6Bs? Okay. All right. So let's look at the top. We're going to solve for a problem here. First off, let's get some parameters here. Let's say we're going to fly to, just do a whiteboard here. Okay. So let's say we're going to fly to La Crosse. Oops. Okay, so the ICAO identifier for La Crosse is K LSE. You don't have to know that, but that's what is it doing? All right, and our let's say we're flying a Cessna 172, and let's see, let's say the winds are out of the northwest. We'll say the winds are 330 at 16 knots at the altitude that we're going to be flying at. Okay, so that's a direction. Again, wind directions are always where the wind's coming from, not where it's going to. So 330 is northwest, and it's coming from that direction. There's our wind speed right there, 16. Okay, so the first thing that we need to do when we're calculating or correcting for the wind correction, we need to find out what our true course is. I just happen to know that the true course or true heading here is going to be let's do true course here, is going to be about, I think it's 69. Maybe look that up again. I don't have a sectional for me, but I can do this real quick here. No, that's right. I can I'll just bring this up here real quick. So let's so we're going from Baraboo, which is the ICAO identifier is K Delta Lima Lima here. And the destination is, and you can use this as well if you want to try this as Sky Vector Maps we're using here. And unfortunately, this actually gives us our magnetic heading, but the magnetic variance in this area is almost 0, so I can almost use that for our heading. So on, well, we've got actually, yeah. So we've got roughly it's 292 degrees to La Crosse from Baraboo, roughly in that area. All right, so let's go back to our whiteboard here. So we got true courses, 200. Two courses, 292. So 292 right there. And now we also need to know the speed of the aircraft as well to do this wind correction to walk through this. So let's say our aircraft, the true speed is going to be roughly 100 knots. So let's put that in there. 100 knots. Let's put a K in there so we know what it's in knots. On the test, they may give you miles an hour, so you'll have to convert. And that, again, that's not a difficult thing. For every mile an hour, every knot is 1.16 miles an hour. Okay, that's just a common conversion you can apply to. So if you're converting from knots to miles an hour, you would just divide your knots by 1.16. And if you want to go from miles an hour to, oh, wait a second. No, I did that wrong, right? So if you're going from miles an hour to knots, you would, let's see, you would divide, yeah, you divide the miles per hour by 1.16 and vice versa for the opposite direction. Okay. All right, so now we've got the parameters there. We've got our true course right there. We've got our basically our speed. We've got the wind speed right there, which we need, and we've got the wind direction. So now let's work through this together. You should have a pencil by your side there somewhere. Everybody should have a pencil. If you don't, let me know. What we're going to do is we're going to walk through this together. Let me just clear this all off here. Oh, I just deleted all that, didn't I? I don't know if I can undo that. Oh, here we go. There we go. All right. I didn't want to lose that. So, and I would write this down. If you have a sheet of paper, you can write it down on a blank area, the sectional in your book someplace. So you've got it. Because like I said, I'm probably going to mess up here and delete that by accident. Okay. So let's get rid of our thing here. All right. So now we're going to go to our wind side. Here's our E6B. That's the front side. That's the calculator side right there. We want to switch to the wind side of the calculator. Okay. All right. Make this nice and big so we can see it. Well, actually, if you look at the top on your E6B on the wind side, you're going to have this awesome tool to help you get your answers right on the exam. All right. Don't miss this opportunity. When you're taking the exam, before you go in for the exam, definitely read this and know where everything is, what it's telling you to do. If you follow these steps the way they are here, I guarantee you're going to get those wind correction problems 100% right. Okay. So you definitely want to use this, and it's totally fine for you to take your E6B in. You have to have something to do the calculation. You can do it all in your head. You could do it with a calculator, a plain calculator. But it's really easy with the E6B. So let's work through this together. All right. So first off, we need to know a couple things on here. On your if you look on your wind side of your E6B, there's this thing called the true index. Let's see, make sure we got that here. And make sure you're okay. You should see it. If you move your E6B around, the little thing, you can slide it up and down like this right here. What you should see at the very top of it is this thing that says true index. Okay, we need to know what that is right there. Okay, true index. We now know that's a fixed point. It's right there. Okay. All right. So the first instruction here is set wind direction under true index. So what do we want to put under this? I can rotate the dial right here. So what do we want to put under that true index? What was it? 330. Yep, exactly. So that's our wind direction. Set wind direction under true index. Our wind direction is 330 degrees. Okay. So we rotate this to 330 degrees right here. That's what it should look like on your E6B right now. 330. Okay. Let's go to the next step. Does everybody understand that? Does everybody get that? Okay. 2, mark the wind velocity up from the center point. This right here is our center point right here. You see that? Do you see that? That's called a grommet. Where the tip of the pointer is right there. That's our grommet. That's because in the old days they used grommets. This one actually still has a grommet. It's a little silver thing there. I don't know if you can see it. On yours, it might just be a little tiny hole. That's called the grommet or the center point. So again, mark wind velocity up from center point. So all they're telling you to do here is to mark up from this center point this number, 16 knots. All right. So I don't care what the scale is on. This could be, up or down. It doesn't make a difference. What I typically do is I can put it at 100 or 110 or whatever. I just move it at a bold line here. So you can see here, this is now on a bold line. I want to mark that up 16 knots. Again, we set our true, the wind velocity up here. You don't want to rotate the dial once you get started on this process here. So that should be 330. And now what you're going to do is you're going to count up basically 16 knots from here. And you're going to put an X where this little dot right here, that's 16 right there. That's, if I count up these graduations right here, I'll get to 16 knots. I know it's 16 because I'm, 110, 120, that's 10 knots. If I go up to this point right here, that's 16 knots. Okay. Does that make sense to everybody? Okay. All right. So now you've got that on there. You guys got that? Okay.
How do you convert the knots to the 130, 120?
You're not. That's your direction right there. Right here, you're not doing any conversion. All you're doing is you're following steps here. So the first step is just to set 330 degrees under the true index. The next step is to set your wind direction or your wind velocity up from that center point, that little grommet, that center point there. And it's 16 knots. That's all they're telling you to do. So you'd follow one step at a time, 16 knots up from there. Okay, now we've done that part. Does that make sense? Kind of.
I don't know how you're getting the 130 from 16.
No, ignore the 130. Yeah, it's again, I could move this anywhere on here. I can move that up to 170. I can move it up to 200. All I'm doing here is I'm counting up 16 graduations of the wind speed here, and I'm putting a dot there above that point. That's our reference point. We're not, again, you could have this on any point on the line. You could move it all the way down on the bottom if you wanted to, and start with 50 knots or 40 knots. I just choose to put it right in the center, just the closest point there. Again, I always line up my grommet, that center point, over a solid black line, so I've got a reference to go up. And again, all we're doing is marking up 16 knots from here. So again, I'm glad you brought that up because that can be really confusing. So, here, again, it's always 16 knots. As I raise this slide up and down, that little slide rule up and down, it's always 16 knots above that center dot there. Yep. And you can actually go to it from the learning portal, but remind me after class, and I'll get you to it. So yeah, you guys can go to this site. This is I think University of North Dakota. They've got an educational site there that has this on it. So again, it doesn't make a difference where we have our center point or where that little hole is right there. We just have to count up 16 knots. Okay. All right. So now let's go back up to the top here. What's the next step? What does it say for our next step? Okay. Set true course under true index. Where's our true course? What's our true course? 292 is our true course. It's right here. Again, that's what we had to figure out what our true course was, 292. So they're saying here, set your true course under the true index. Well, where's the true index? The top, right here. Okay. So our true course is 292. So I'm now going to slide this over to 292. That's what your E6B should look like now. 292 right here. The little dot that we created is off to the side now. Okay. Okay. Has everybody got that? All right. What's the next step? Yeah, okay, on mine it says it differently here, so yeah, on this one, and that's fine. I just want to know that that's correct. That's correct. So slide wind velocity mark to true airspeed. All right, so let's take a look at this. Slide the wind velocity mark. Well, where's the wind velocity mark? Yeah, the little X that we made over here. That's it, right there, right? On your E6B, that's why you want to use a pencil with these. Never use a pen. You can erase the stuff if you put a little X on there. You know, on there, you can always erase it with your pencil, and make sure you have a number 2 pencil too. I think the test they provide you with one, but if you're doing these calculations, always have a number 2 pencil with an eraser. You can always clean it off, I'm sure, with some sort of old school cleaner or something like that. All right, so let's get back to this. So slide wind velocity mark to true airspeed mark. Okay, well, what's our true airspeed? 100 knots right here, okay? So we want to slide this X that we made there when we marked up 16 knots, right? We want to slide that to our true airspeed. So we go slide this down to the 100 knot line right there. See that? Okay, so there's a little 100 arc there. You can see that. That's what your E6B, this would be where you would have the little cross there on there. And then, okay. Does everybody have that? Does that make sense to everybody? Anybody, so far, does anybody have any questions on this at all? We're good? Okay, all right, I just want to make sure everybody is good with it. All right, so now one of the last things we're going to do is ground speed reads under the center. It should say ground here, but under the center. They're talking about that little center dot there. What does it say on your E6Bs?
87.
You're 87?
85.
At 85? 86, 87. Okay. It's roughly about 86, 87. Yeah, it's in that area there. So that's where your little center dot on your E6B, that grommet, that should be over that point if you did the calculation correctly. Okay. So that's going to be your ground speed. Okay. If you're really into geek out on some of this stuff like I do, I would like to know why this is working the way it does. You know, it's what I do is sometimes I'll draw a plane on the center dot, so I know what the plane is going to be doing or whatever. But if you get into the what's happening here with this, it makes sense. What they're doing here is just an ingenious design. Now this same E6B is the one that they used in World War II. They did circumnavigation of the entire planet using this. They didn't have any fancy iPads or iPhones or anything like that. They did it all with slide rules. And they were very precise. I flew with, just as an anecdotal story, I flew with an old guy who got me into the Twin Comanche anyway, a long time ago. And he flew back in the 50s. He was a commercial pilot. And he was really big on, pre-flighting and, knowing exactly the minute you would land. He would really get upset if you didn't plan out your flight and know what minute you were going to land. It was that precise. He said, every flight you do, you should be able to land within minutes of, of your, regardless if you're, traveling across country or whatever. He said you should always be able to know precise time that you land. And so he got me into using the E6B and using it well. I don't know it as well as I used to, but in any case, that was his big thing. And we did flights, down to Florida, and we literally be within minutes of our arrival time we planned on. But again, that requires that we know what the winds aloft are, and we know all these other conditions that are happening. There's more to it than that, but essentially, you have to make yourself aware of all this stuff and then apply it. And what we're doing here is we're taking all the things that we know so far about the flight and we're applying it to the E6B to get it. So yeah, these things are great, and they don't need batteries. They always work. Not saying that the E6 or the ForeFlight isn't great. It's awesome, but these phones overheat, iPads overheat, and they shut off. And you don't want to have to land in a farmer's field just because your iPad died on you. You want to get to your destination, using this right here, I can, do it accurately. All right, so you've got this. So what's the last step here? It says on here, wind correction angle reads under center line and wind velocity mark. Okay, so let's take a look at this. This is the center line right here. And notice on this side, it's positive right here. And on this side, it's negative. And I don't think they actually show that here anywhere that it's negative, but this is going to be the positive side here. It does show that it's negative on yours? It doesn't, okay, yeah. On some of them it does. So with this is going to be positive, this is going to be negative on this side, okay? So what it's saying here, or wind correction angle reads between the center line and the wind velocity mark. This is the center line. This is the wind velocity mark. How many degrees of correction do we have there, roughly? Yeah, it's about 6 degrees of wind correction. And we're adding that to our thing. Now, let's think about it. So we're going from variable. Let me just draw this out. So here's variable right here. Just a little X there. There's lacrosse. Okay. So this is our course line, right? It would be basically, from here to here, right? That's roughly 292 degrees, 292, right? Okay. So at this point, we know we've got wind coming out of the 330. So the wind looks like this right here, a little arrow there for the wind at 16 knots there. So what direction is the plane going to have to turn in to counteract that wind so we get to lacrosse instead of winding up someplace over here? Yeah, you're going to turn the aircraft instead of pointing like parallel to that course line. So here's our plane right here. The plane is actually going to be more like this. Right there. That's I moved it away from there because I didn't want to interfere with that line. But basically, that's the angle. That's 6 degrees off that. That makes sense, right? We're adding 6 degrees onto our true course to get our true heading there. So let's take a look back at our cheat sheet up here, which again is phenomenal that they allow you to have this on the test. True course. Now that's our true course that we just came up with the plus 6 degrees there. So now we have to take the next step is we have to figure out the lines of variance. So does everybody know what the variance, magnetic variance is? Everybody remember that? On your sectionals, do you remember what the magnetic variance was? I take a guess what that is. Right. And that's these dashed magenta lines that you're going to see on your sectional. So what you want to do then is go to your sectional and look for one of those dashed lines. And let's see if we can find it. Maybe you guys can find it quicker than I can here. So where is, I'm looking for, oh, there it is. Okay. That's kind of buried in there. Let me just go up a little bit further here. So what I'm looking for is a number on that line. There we go. See that number right there? 2 degrees west, it's saying. Okay, that's our variance line, all right? So let's go back to our E6B. So true course, we subtract east variance, we add west variance. Okay, so now we started out with what was our true course. Originally our true course was 292. We had added plus 6 degrees for our wind correction angle, 6 degrees. So that now equals our true course is now 298, right? Mm-hmm. That makes sense because we're turning into the wind to counteract it. Okay, 298 is the true course of the wind correction angle there. And now we want to solve for the magnetic variance in our area. Again, around here we're really lucky because we're almost in line between with the magnetic North Pole and the true North Pole. But you go over to like Vermont or Oregon or something like that, and it's going to be like 20, you know, maybe 23 or 24 degrees variance. So that's a huge difference, and you have to make sure that you calculate. And indeed, on the exam, the FAA exam, they do not use Wisconsin because it's we have almost 0 degrees variance. You're going to be in Vermont or Seattle, and I think it's going to be Seattle when you get the test questions. So these sectionals that you have here, get used to reading all the different information on there. Start looking for those lines of variance, magnetic variance on those. You should be able to find those pretty easily and looking up the number on there. So our magnetic variance is 2 degrees west, right? Is that what it said? 2 degrees west. Okay. So that west or east makes a difference here. So here they're saying true course plus a west variance. So we're going to add 2 degrees onto our true course, and that's going to give us our magnetic course. Okay. So we add 2 degrees on it. What do we get? 300. Okay, 300. That's our magnetic course, 300 degrees magnetic. We're not done yet. All right, so that's magnetic course right there. All right, now we have to solve for, they've got the wind correction angle here, I guess. So I actually calculated the wind correction angle before, which is not going to hurt anything, as it still adds up. They've got here, this is what we just did here. We added, to the right. So on this side, this is the right side. And we had, basically 6 degrees to the right here. So to convert to, again, we've already done this, so we don't have to do this right now. We take our magnetic course and we add that 6 degrees and that wind correction angle, that 6 degrees wind correction angle, and that's going to give us our magnetic heading. So we've already done that. So this winds up being right now. This is now our magnetic heading, that 300 degrees on there. So you could actually follow the steps here. Do this one here first, then this one, and then this one, and you'll get the same results on there, because all you're doing is correcting for various factors here. So I really should have done this in the manner that they have it there. I don't know, on yours, does it show first calculate for true course and then for magnetic course? Is that what it's showing on yours? Is it the same formulas here?
Yeah.
Okay, good. All right, so the WCA stands for wind correction angle, and that's this down here. That's your wind correction angle. That's going to be 6 degrees. Okay, and it's to the right, not, so if your dot's over on this side, it's going to be a negative number. 6 degrees positive, correct. This would be over here, it would be 6 degrees negative. Okay, so now the last thing we need to do is to calculate for the magnetic or the compass heading. And this, we need to go into the plane to find out what the actual compass heading is. Does anybody know why we have to go to the plane to do that? Yeah, compass, right? Is that what you're going to say?
Because of interference from the engine.
Perfect. Yeah, that's really good. Okay, great. Good job, guys. All right, so every plane, yep. Mm-hmm.
If you're a really long flight, how do you plan the course because of the wind?
So yeah, that's a good question. So let's say you've got a super long flight and it's like, okay, yeah, the wind's going to be changing. Yeah, it does. If you're flying through a high pressure area, you're going straight through it. The winds are going to be totally opposite on the opposite side of the high pressure area, and same with low pressure area. So what you do is you break your flight into legs. You do a leg. Generally speaking, you're going to do maybe 100-mile legs or something like that. In some cases, when you're a student pilot, you're only going to do maybe 15, 20-mile legs. So you're going to break your total flight up into smaller segments, and you're going to calculate it based on the area. But good question. Okay. Does everybody understand that? Okay. All right. So for magnetic heading, again, or compass heading, again, that's what CH stands for, is compass heading. MH stands for magnetic heading, and the DEV is deviation. Don't get that confused with variance, VAR. That stands for variance. That's the magnetic variance because of the Earth, the distance between the pole and the North Pole, the true North Pole and the magnetic North Pole. Deviation has to do with what is on the compass card. So let's take a look at a compass card just so you can actually see what this is. And again, every aircraft has to have this in there because there is interference from the engine, like you said. You've got other, equipment inside the cockpit that has some metal in it, has some magnetism, and it's throwing that compass off a little bit. But once it's installed, that equipment gets installed, that compass will always read accurately the same way every time, unless you introduce something else. You bring in a big magnet in the plane or something like that. It's always going to read the same things, but it's going to be wrong. If you were just to solely use that, it would be wrong because of all these little tiny things that are fixed in the airplane. They're causing it to shift, the magnet to shift there. So let's clear this off. I'll leave that on this now. Let's see, there should be this card here someplace. Here we go, right here. So this is typically what you're going to see on the compass card. So they've got, for a magnetic heading of north, for instance, on this compass card, and this would actually be right on the compass. I don't know if I've got a picture of that. I guess I don't, but this is just a little tiny card. If you look inside that plane over there, if you look at the compass, you're going to see a little tiny card there. Sometimes it's a placard on the panel there, but usually it's right next to the compass, or right below the compass itself. So what they're saying here, for if you have a compass heading of north, you want to steer to 0, which is north. So there's no deviation there. That's what they're saying. However, if your magnetic course is 30 degrees, they want you to steer instead to 28 degrees. So we've just, that right there is our compass correction right there. And again, they've got basically all the headings here. You can kind of interpolate between different headings here. So south is, is 180 degrees. That doesn't change at all. 210 is off by about 2 degrees there. So for, in this case, we're going to the north, and it roughly, let's see, yeah, well, actually 300 degrees. So ours, that's the greatest deviation right there. So we would steer for this plane, this problem that we did, we had a magnetic course of 300 to correct for magnetic deviation of the compass. There's what we steer for magnetic 300 degrees. We want to steer for 303 degrees on the compass. Okay, and you'll actually read it on the compass. Now, in real life, when you're flying a plane, watching that compass do this all the time, it really makes it tough. This is where, having, like ForeFlight or something like that is going to be helpful. The other thing is you're going to be looking outside the aircraft, looking for checkpoints, especially as a student pilot. When you go up and fly, you're going to be looking out all the time. Don't make the mistake of burying your head inside and looking at instruments. It's the worst way to start flying. You want to use all the outside references. It's going to help your flying. Later on, when you go for your instrument rating, yeah, you're going to have your head inside. As a matter of fact, you're going to have a hood over your head so that you cannot see outside when you're doing your instrument rating. But for your private pilot, you should be looking outside all the time. You should be, glancing out and seeing the horizon, looking for landmarks, cities, and things like that. Donnie, did you have a question? What's that?
I don't think it's glasses.
Well, you can use hoods or glasses. They've got all kinds of devices. I've seen some where they actually put like a colored film over the windshield, and the instructor doesn't have any glasses on, and the student has polarizing glasses on. And when they put those on, they cannot see outside the aircraft at all. That's another method. Even a baseball cap with little side things on it is fine to use as a hood. What you're trying to do when you do the instrument rating is you want to limit your outside view, so you're just looking at the instruments. And typically the hood is going to be something that looks kind of like this. I've seen like the glasses that are fogged over the top right up above here, and then down here you can look at the thing. So anyway, you're going to be looking outside, so you won't have to worry about that. You will, in your student pilot training, you will actually put those hoods or those flight or visual restriction glasses on or something like that to restrict your visibility, to just practice it. But you'll find that it's very challenging to fly a long distance without looking outside. So you want to get used to that. All right. No, you're not. As a student pilot or as a private pilot, you're good enough to fly in VFR conditions. You can't go off into the clouds as a private pilot. That's when you need the instrument rating. Okay. All right. So let's see here. Yeah, actually, Andrew, I think the on 16-9, they've got a diagram where you've got various checkpoints. Those could actually be individual flights there, but that's a fairly short flight. But you may have different winds aloft and things like that that you're going to use for your wind calculations there if there's a really long one. Gives you an idea of how you plan out a VFR flight. You're always looking outside and verifying locations there. Okay. Any questions on any of that stuff? Everybody good? Good. Good. All right. All right. So let's clear this off here. All right. On your E6Bs, everybody should have a booklet with your E6B. They've got sample problems in there to as far as using the E6B. Let's maybe do a couple simple problems on the E6Bs just so you know how to do the time and distance calculations and stuff like that on there. So I think they don't really talk much about it in the book, but all right. So on the E6B, there's a couple areas that we need to point out. There is probably the most prominent point on this is on the front side of the E6B here on there. There is a little triangle, and it might be larger on yours, it might be smaller. This right here is that's called the speed index. That's that little triangle that's on there. You can see it right there on my E6B, that little triangle thing there. My finger is. That's called a speed index, right? You need to know what that is because we do a lot of calculations based on where that is positioned there. And then you can see there's other arrows here. A lot of answers for the FAA questions can be figured out just by reading what's on here. If you just look at the slide rule, they've got instructions on how to read, set pressure, altitude, or altitude correction, airspeed correction, things like that. Right here, we've got, I'll show you how to do this here in a second, but you can figure out your time and distance calculations using this method right here, and I'll show you again how to use that in a second. And then fuel usage, here, time, distance, duration of fuel usage, all of those things can be calculated again on this simple E6B. So let's actually get into this, and I'll just show you. I don't want to spend a lot of time on this. This is something you can take that booklet out at home. I would definitely encourage you to go through that booklet and go through their sample problems and make sure that you can, come to the same conclusion that they're coming to and get comfortable with it. If you do have trouble with it, you can always get a hold of me, and I'd be happy to work with you on it. Right. So let's actually go back to our E6B. Now we're going to switch to the slide rule slide, the calculator side of it. So, all right, so we're going to, well, actually, I don't know where I'm going to fly today, but I've got 2 hours of fuel and I've got a reserve of 45 minutes. How far can we get today if we travel for 2 hours at 100 knots? All right, that's the problem I want to solve for. Okay, so to do that, we've got this handy little reference down here. So set your miles per hour or knots under the true over the true index. So this, you'll see that your slide rule moves this like this right here. This, by the way, this outside ring is called the outer ring appropriately. This right here is the inner ring, and there's two different levels of the inner ring, but they do basically the same thing. You've got this right here that if you added 10 onto that, you would get 140 minutes on there, and we'll get more into that a little bit later on there. So let's say, all right, so what we want to do here is we want to calculate how far we can get in 2 hours at 100 knots. All right, so we set our speed over the true index, that little dot right there, that little triangle right there, that's the true index. All right, there's our true index. Where do I slide this to? Our speed is 100 knots. What should I do with this? Yeah, put it on 10. Yep. So again, we don't have 100 on here. You can see on the outer scale, it doesn't say have 100. But all we have to do is we can make the assumption that we can just add a 0 onto that. Now it becomes 100. Okay. And you may do that a lot. If I was, let's say, flying in a F-16 and I'm doing 100 miles or 1,000 miles an hour, I could go ahead. I don't think they go that fast, do they? F-16, they do. Does it go a lot faster? Yeah, I see. I don't know anything about it, so, and you would know. So okay, so that speed index goes under the 100 there, or the 10 right there. Okay, so now we've got that. And if you look at the formula here, so it's set miles per hour over that speed index. We've done that, and you can read your distance on the outer ring and your time on the inner ring. So we know we want to travel for 2 hours. So I want to go on the inner ring. I want to go to basically 120 minutes. And you can, this is, if you can see where the pointer is, I'm on 12 right there. And the true index is still, or I'm sorry, that index mark is still pointing at 100 there. But if I look at 120 minutes, which actually just below that on this, the far inner ring, you'd see it says 2 hours there. Does everybody see that? You look at 120 or 12 on the inner ring there, just below 12 is 2 hours. Well, that's because 120 minutes is 2 hours, right? 2 hours, 60 minutes is an hour, so that's 12. And if you look at the ring, that's what you're going to see throughout the ring there. So it just makes it a little bit easier converting time. Okay, everybody with me so far? Okay, all right. So how far can we go at 100 knots? So if we look at our formula, or the guide right here, so we've set our 100 knots under the or over the speed index, and we're reading our 2 hour time right here on the inner ring. What shows the opposite on the outer ring? 20. Okay, so we can only go 20 miles. 200 miles. Yes. Remember, we added 10 to here, 100 knots. We're going to add 10 here. We're going to get 200 nautical miles. Okay. And I could, if I started out at 100 miles an hour, this would be statute. I'd read it as statute miles. Okay. Also, just so remember, use the same units if you can. Nautical miles an hour are knots. So, okay. All right. So yeah, that's how you do it. And again, that's all done with this simple formula right here. Set this. Let's try another one. Somebody give me a number between 1 and 300. What was that? 299. All right. So so you guys are we're in a let's see what would that be? Oh gosh, a turbine. Well, let's say we're flying in an Epic aircraft, which is a turbine, a really nice aircraft that was actually designed by one of the guys that started Cirrus here at Baraboo. Anyway, he built this Epic aircraft, and it can fly at 299 miles an hour. All right, so where do we put the speed index? You guys got to do this for me. You got to help me out. Where are we going to put that speed index? Okay, so we're going to rotate this. Oh, yeah, gosh, I don't know if I can. Sorry, Jen, I don't know if, let me see if I can zoom this in a little bit more. Is that a little bit better, Jen? A bit, okay. Let's see, yeah. I don't know if I can make it any better than that. Okay. So we want to rotate this speed index until we get to just below the 30. So the speed index is going to be pointing at basically 299 right there, right? Okay, that's our first step. All right, so the next thing is, how much fuel do we have on board? How many hours of fuel do you think we have? So somebody just give me a number. How many hours? What's that? Hour and a half of fuel. Okay, so we've got an hour and a half of fuel. All right, so you guys now know you've got all the variables for to solve this. How far can we go in a no-win situation? How far can we go? You guys tell me. Okay, 540. What are you guys getting? We said an hour and a half. So we look for. So let's actually walk through this. So how many minutes in an hour? You said an hour and a half, right? Okay. So how many minutes in an hour and a half? Yeah, 90. So we read it off here. So now we know we're right in this area right here. And it's just conveniently below that on the far inner ring. It says hour and 30 minutes, but it's 90 minutes. All right. So you could see that 90 minutes is just shy of 45. So how many miles can we go? 45? 450. Yeah, 450 miles. Okay. So that's how easy it is to use this. And again, you have to do enough of these to get comfortable with it. Plan on, throwing a bunch of different problems in there. You can use SkyVector as a reference too. That'll actually give you correct answers on it. But you want to get used to using this because again, you're going to be doing, at least 2 or 3 of these questions on the FAA exam there. All right, so now let's do the same thing, but now let's calculate for fuel usage. So we've got, again, that same speed index right there, that little triangle right there that always corresponds to that right there, okay? So if, let's say we burn 15 gallons an hour, okay? So I'm going to rotate this over to 15, right here, 15, right there, 15 gallons per hour. And then we're going to be in the air for 6 hours, let's say. It's a really long flight. You burn 15 gallons of fuel. So, and again, keep in mind that a lot of these things we could just do with, or in our head. We can calculate it in our head with the basic formulas there. But with the slide rule, it just makes it so much quicker here. So we've set our 15 gallons per hour usage right there. On the inner ring, let's say we're going for 6 hours. Okay, so there's 6, which is 350 minutes. Okay, or over about more than that, 360 minutes. I'm sorry, 360 minutes. That's on the inner ring, so 6 hours, 360 right there. And opposite that, we read 90. Is that 9 gallons? Is it 90 gallons? Is it 900 gallons? What would it be? Yeah, 90. Again, use a dose of common sense here. You could do this in your head, right? We're traveling for 6 hours. We're burning 15 gallons. It's just, 6 times, the 15 gallons that we'd have it. But again, now when you start getting to more complex calculations, this can make it a little bit easier, as far as calculating when you've got the things that are switched. So that's basically though how the E6B works there. So the other thing that you're going to calculate for is airspeed correction, and altitude correction using pressure altitude. So this is kind of another area, and it's really tough. Does everybody remember what the definition of pressure altitude is? Yeah, it's more specific than that. It's the theoretical standard datum plane. Basically, so right now, if I go to the weather here, let me just bring this up here. Weather. So right now, Baraboo is reading 29.5 inches of mercury. Okay, so that is, well, first off, what's international standard atmosphere? Everybody should know this, by the way. When you go and take your test, you have to know what an international standard atmosphere is, or ISA. What was it? 29.92 what? Inches of mercury. Yep. And then what's the standard temperature of the international standard atmosphere? 59 degrees Fahrenheit. What is it for Celsius? 15.7, I think. Is that right? 15.7 Celsius. 15.2, something like that. I know it's not quite exactly right there, but but yeah, it's everybody. You should know that though. It's roughly 15 degrees Celsius for that, because we need to use those in calculations for correcting airspeed and altitude corrections for pressure altitude. Again, all the performance charts and everything that you see in airplane handbooks, they're all going to use pressure altitude. So it's not enough to use your barometer setting that you read off of the website or wherever you go to get your pressure, the current pressure at the airport you're at. You have to solve for pressure altitude. So first off, to find out what pressure altitude is, let's see. Actually, there is a good diagram in here that. Sure, let me just take a look and see if I can find that. There we go. Okay, so and I think you guys, let me just zoom in on this so people at home can see this. So this is the table for correcting, from whatever your pressure reading is to pressure altitude here. So to figure out, so right now let's figure out what the pressure altitude is at the Bearwood Hills Airport. So again, our current pressure reading is 29.58. Let me just write that down here. Okay, so our pressure at Bearwood is 29.58 inches of mercury. Okay. So we need to figure out what our pressure altitude is. And again, it's a pretty simple formula. It's easy to get lost in. Yeah. Oh, thank you. Yeah. Let me just clear that up. Okay, so 20. Okay, so 29.58 is what we have at Bearwood right here. So pressure altitude at this airport, we'd have to use this table, or we could just use some basic math, and I'll show you how to do this. Remember that every inch of mercury that you that goes down, you're going to be sorry, let me just make sure I got this. Oh, I'm sorry, I'm using the wrong one here. Here we go. This is the actual as you climb through the flight levels. This would be the international standard atmosphere for each different flight levels. We always use this one right here as our ISA, or international standard atmosphere. Again, sea level at 0 feet, 29.92 and 15 degrees. That's our standard atmosphere. And again, committed to memory because you're going to need it. Okay, so let's go to the table I really want here. All right, to get to pressure altitude, we need to adjust. We need to kind of figure it out. So right now we're reading 29.58. What we want to do to calculate it through math, we just take 29.92 here, and we subtract it from our top number right here. So is anybody good with math? You can figure it out real quick. Is that like 34.34?
Yeah.
Is that right? Okay. 0.34. We get 0.34. It's actually minus. Right? Okay, so 29.58. That's our current altimeter setting at Bearwood. And then we use our ISA, our standard atmosphere is 29.92, and we get 0.34. Now there is another factor in here. Let's see if I can say something. Okay. Right, so that's minus 3.4. What we can do then, we know our field elevation at Bearwood is roughly 920 feet. All you have to do is multiply this number right here by 100. Okay. So if it's 1.34, which would be excessive difference, but if it was, we'd multiply that by 100 there. We'd still, in this case, we would get, what is it? Three. Oh, wait, I'm doing something wrong here. I'm not. Negative, yeah, negative 34, thank you. Yeah, I just did something wrong. So it's minus 34 feet. Okay. And so to get to our pressure altitude, we'd subtract 34 feet from that number, minus 34. And we get a 890, or minus 34. I'm sorry, I got this wrong. We get 880. Oh, jeez. Okay, doing a horrible job of drawing a. Yeah, it's a negative number right here. That's the number. That's the result of this right here. So again, let's walk through this again. This is the altimeter setting at Baraboo right here, 29.958. This is the standard. Which this is you're always going to subtract this 29.92 from the altimeter reading, and this is your result. In this case, it's minus 0.34. We're going to multiply that by 100, and you're going to get minus 34. Okay, and then you're going to take that and apply it to the field elevation, whatever elevation you're at, and you're going to get your pressure altitude, which in this case is 886. Now let's think about this through common sense. All right. So if let's see, maybe I did this wrong. Maybe I did this wrong. So let's see. Just use their table. So I did it through math. This is the table right here. So if the altimeter setting here was, we said 29.58. And see, correction 392. Yeah, I think I did something wrong here.
We don't have to this flow. It's
What's that? Supposed to add it. Yep. Okay. Yep. So I think what I should have started out. Sorry guys. Yeah. 29. This is what I should have done. And correct me if I'm wrong on this, Preet, but 29.92. Start with that on the top and then subtract your. Thank you. Yeah. Okay. Sorry guys, I should have had that. So 29.58 inches mercury. And what do we get here? Yeah, 0.34. Okay. It's positive this time, 3.4. Okay. Right. They multiply that by 100 here. And then we have 34, right? 34 feet. Is that right? Yeah, 34 feet. And then we're going to add that to our field elevation, whatever we're at here. So at 920 here at Baraboo. But it depends on where you're at on the field here, you know. So yeah. So at 960 or 920, I mean, again, it depends on where you're at on the field there, but we'll just use 920 here. So we add 34 to that, and we get a pressure altitude of 954. Okay. Now let's take a look at the mechanics of this, just so you understand the common sense workings of this behind the scenes. All right. So it makes sense. First off, our pressure is lower than standard. Are we going to have better performance or lower performance if the pressure is lower? Just without even looking at these numbers. Lower performance. Yeah, because the pressure is lower, right? Okay. So this is starting to make sense. Now it's acting as though we're at a higher altitude, which would be lower pressure, right? Okay. So we now have 954. We're actually taking off at a slightly higher altitude airport. That's what pressure altitude does for us. You know, you're standardizing the numbers there so that you can plug them into formulas in the POH, your pilot's operating handbook, your flight manual, so that you can come up with performance numbers. That's why we need to do that. So I'm sorry I goofed it up. So again, start with 29.92 for your international standard atmosphere, subtract the altimeter setting for the airport, and then you're going to get a number, multiply that by 100, and that's going to be your correction for the field elevation. Does that make sense for everybody? Okay, all right. So if you're actually in the aircraft, is there anything you can do that would make this a little bit easier? So in the on the yep. So on the altimeter, yeah, there's a barometric correction, barometric barometer correction, or what we call the Foldsman window. There's a little knob on the altimeter. If you just set that to 29.92, you're going to read your pressure altitude right on your altimeter. That's the way it works there. And again, here we're doing it with math. But now we've got it so that we understand, you know, we can do it with math, which you're going to need to do when you're on the test, because you're not going to have an altimeter in front of you on there to set it. You're not going to certainly have the same pressure that they give you in the test there. So, all right, does that make sense for everybody? Any questions on that? Okay. Let's see what we have for time here. Let's take a good 15-minute break, and then we'll come back and answer any other questions that you have, and we'll maybe go into some of the weight mail and stuff too. Yeah, yeah.
Are dry erase markers?
I'm sorry?
Are dry erase markers?
You know, I've never tried. That's a good question. I've never tried it. It would, yeah. The only problem with the dry erase is that they're usually like really big. Well, they're big, but they also they wear out, but they're also really big. I mean, you're trying to get to a very narrow point on there, you know, on that. So using a pencil, you've got a very precise point, and you can go from there. So, yep.
I don't understand it. Yeah, I was like,
Hey, just making sure that you got the up and moving.
Yeah. Yeah. So it's, yeah. You could actually do these in any order. You'll still get the same result with them.
Sounds good.
But it's just the method of, I was like talking about wind correction angle. On this one right here, we do the wind correction angle first, and then we go to the true heading. On there, they had it just the opposite.
Oppositely, yeah.
Yeah. So,
Now I have it like correction density force,
Uh-huh.
magnetic force,
Yeah.
and then doing it.
yeah,
So-
it can be very confusing. As all you're doing is just adding and subtracting numbers here, and eventually they should all yield the same number. It's a different step in the thing, and you know, it could be confusing for somebody. I mean, and it threw me for a loop. I said, wait a second, it's not right. It's like, oh yeah, because we already calculated it. But yeah, it just, again, what I always tell students though, and you've already taken.
Yeah.
Yeah,
It
so,
is fun.
but
I have to take it again.
Oh, you do?
Yeah.
Oh, no.
That is bad.
I'm going to try to set up a testing computer up here that's actually going to simulate the real
Oh,
test. So if you want to come up sometime,
Sure.
you can do it online too. You know,
Yes.
where it'll actually, actually give you the results on it. But it's, we use Springs.
Yeah. Oh, okay.
It's, so you
I
can-
think I've taken some mock tests for sport. But I would like to do it again.
Yeah, Sporties is great.
Yeah.
It's fantastic. So, yeah. Yeah, I don't know. There's a lot of, there's a lot more you can do with these things. You can do with this. I can calculate text with it. But it does multiplication, subtraction, division, all on it. It's amazing. We don't use these more often. I just, you know, and the other thing is really nice about this, if you have all your numbers plugged in here and you hold it like that through the entire flight, you don't even have to look at your. It's right. So there are advantages to it. I've had some other instructors tell me, "Oh, it's like, you know, it's like we don't use it anymore." I feel it's like, you know, I think this is something.
I don't even trust any of sectors because if something like minute thing, if you don't even realize and you change the unit,
Yeah.
it's going to be crazy. Like, what if bias change or not because bias just saturates?
Uh-huh.
And
Yeah.
it has happened once and the student was getting like weird answers and we don't even realize that. That's
Oh
crazy.
my gosh. Yeah.
Something like that.
Yeah. I always back it up with this, and like I said, again, aviation is always a good rule. Yeah. Anytime you flight, you just have to use common sense. Looking at computers, I always tell you, and sometimes I just feel like way too helpful. Or it is convenient. It takes a few seconds to plug in the flight plan. You saw me put it there, it took a couple seconds. And plan it out, and probably take 5 minutes. It does everything. It calculates all the ones. He did. Well, hopefully this next week or so. So I'll let you know as soon as it's done.
Okay.
They're doing a great job. They've got they've got all the parts are either in or going to be. It's got to clean up
When is the annual check after that?
They'll be done with that.
Right after that. So
Yeah.
annual takes like 1 day or 2 days.
Well, it depends. Like, so the annual was actually completed, with it, but it's all the spots that found all the discrepancies in it. So they're going through it. Yeah, and it's still.
Are there any like updated AEs that are need to be corrected?
Oh, they've already said.
Oh, wow.
Yeah, that's me. These guys are super. You guys are.
Oh,
I mean, not that the other guy was bad. He's just a different. There's something he inspired these guys don't.
yeah.
So it's good things like that. It's bad things. It's like this pocket, but I feel a lot safer.
Yeah, let's start. But I think you already like started the procedure. But I yeah, I don't know why they are not ready because usually before it was like I don't know. But now I think it was changed the process and the
Okay. All right. Yeah, I'll take care of it. I want to make sure that the plane is ready to go.
and then within the next 2 weeks of the start date, we need to talk about it, otherwise it gets canceled.
Okay. All right. I gotta do. Remind me of that.
Sure.
I always tell people, if you tell me something, you
Yeah.
really want to remember it. I live on it. It's like my brain. So, but yeah, I'll do that. I gotta talk to this jump.
Yeah, and here
Yeah, absolutely. No, that's fine. So we're just gonna talk about it.
oh, okay, so then we will just take the
Yeah. That's what it's saying.
I drive a 9-hour flight. I think I think if I don't do it right way, I think that I need to book jobs. This is not precise.
Well, I think you should make this more of a means.
I never say that. I said it in school. That's a problem.
I'm sorry. I it's like with chemistry and education. So that's I did that right. And so thought about it for chicken. Yeah.
We'll see. I'm afraid we'd lose a few. We've got lots of.
So. There's like some great. So there, take it about.
Well, so so they'll have a nice large.
I see so. That's fine.
However, it should be.
Yeah, it's gonna be easy. Yeah. All you have is 6 and then it's spelled out.
It's cool.
Oh, thank you. Yeah. So,
Not yet. Other products.
All right.
All right, everybody, let's head back. We have
Okay. Does anybody have any questions on pressure, altitude, all the stuff that we've talked about?
Next week, will there still be like a optional class here?
If you guys do have questions, I can make myself available at the SIA office. You guys are welcome to come there, and I'm happy to answer any questions you have. If you want to work through some problems on there. And for the people at home too, if you guys, you're welcome certainly to either call me directly. I can talk with you individually or whatever. You can always email me, joe@studentsinAviation.org. If you want to set up a time outside that, I'll send you a little booking link, and then we can set up a time to work on whatever you have questions on. So yeah, I'll probably be here next Saturday. Morning, probably about the same time. Okay. What's that? Today. Yeah, that's fine. We're just going to cover aeromedical factors, which is really simple. I mean, actually, you guys could just read the aeromedical factors out of the book, and I can't really add much to it. You know, I can explain a couple things there, but we're actually not going to be done here early. The one last thing that I want to talk about is VORs. So so navigating and with VORs is always a bit of a challenge. So let's talk about that. So on the sectionals here, and you can, if you want to, you can open up your sectionals. Just try keeping quiet once you have them opened up there, but you're going to see these VOR stations here. They look like this right here. This is a VOR. Let me just show you the actual symbol for one here. Okay, here's Baraboo right here. There's the Baraboo Dells Airport. There's the VOR station itself. That's the symbol for a VOR. Let me zoom into that. You see it's like a little octagon right there. That's a VOR symbol on a sectional chart. That's a station that emits basically 360, you know, lines, or we call them radials. You won't see it, you know, obviously on your sectionals, you'll have to look for a blue compass rose essentially. And then at the very center of it, you're going to see this little symbol right here. Again, that's the symbol that you're looking for. And on the outside, you're going to see this blue segmented, you know, conical line, there's a circle right here. And you can see, if you look at that circle, you've got, it starts at 0, which is what? That's north, yep, okay. And now one thing that's really important for you to understand with VOR stations, do you think that they point to magnetic north or true north? How many people say true? How many people say magnetic? It's magnetic, correct, on that. And that's because when you're flying in the plane, you're referencing, you know, these radials from this thing right here, so they can adjust that over time. Whereas latitude and longitude, not so easy to use in the plane. You're flying in the plane, you're going to have access to these signals here. So let's talk about how this works though. So they have radials, there's spokes that come off of them. So let's say here's a spoke right here that's right at the 60-degree line. So this is known as the 60-degree radial right here. Okay, that's the radial. If you are on that radial, let's say your plane is right here at this point right here, and you've tuned your VOR receiver, your bearing selected to 60, it's going to be centered up. Now let's take a look at what that looks like in the plane. But I just wanted to show you what radials are. Radials, this is an important point. No, for two things. Number one, they always point to magnetic north, okay? And they also, the radials always emit from the station. Remember that. From is a very important word, okay? Radials always emit from the station. The reciprocals are always to the station. So the reciprocal of 60 is 240, right? 180 degrees. So that's the reciprocal. So 240 in this case, you can see the tell there. Just I can't do this without that out there. Let me just draw this line straight through here. So I'm going to draw from 240, oops, to 60. Okay. Oh, it's right here. So this right here is the 60-degree radial. This is the reciprocal. This is 240 degrees right here. This would be the 240-degree radial. The reciprocal that would, or the oh gosh, let me back up and make sure I get this right. So again, the radials always emit from the center of the station, and they're always from. The reciprocals are to the station. So this is going to make more sense when I actually show it to you in the cockpit, what it looks like. So let me just bring this up here real quick. Oops. Take a second to show up here. Yeah.
Like on I used to be organizations like GPS.
Not even use GPS?
Yeah, like by choice.
Yeah, I have. I mean, some short flights, I mean, like to La Crosse, you don't need a GPS. You know, sometimes I always have a GPS map on just because it does show other traffic. But oftentimes I won't even look at it, you know, other than, you know, if I get an alert or something like that, a traffic alert or something like that. You know, so you really don't need GPS to navigate. As a matter of fact, we never had GPS. We didn't have Loran or any of that fancy stuff up until the 80s, you know, and even then that was expensive equipment back then. GPS really wasn't introduced until the mid 90s and usable, let's say, until the early 2000s. You know, that was then it became much more useful. We just bring this through here. Right. Yeah, so again, you really don't need to. You can use pilotage, which is just you looking outside the window, you know, and saying, okay, there's Reedsburg. I know I'm heading west. We're going toward, you know, La Crosse. And I see, okay, Hillsboro's up ahead. That's a checkpoint. Okay. Then you go on to your next one. You typically want to keep your checkpoints so that they're no more than like 10 miles apart if you're going to do that pilotage. Only because you want to be able to see the next one fairly quick and spot it. If you got low visibility, then yeah, it's not the best idea, you know, to do that. So you're going to use dead reckoning, which is deduced reckoning. You know, you're deducing what your course would be, you know, what your compass heading would be based on winds and things like that. You're going to use that, and then that's going to allow you to fly an estimated course to the location. And you should know the speed of your aircraft, and you should know how much time it takes to get there, and then you'd have it. So there, you know, we never had GPS back when I started flying. Anyway, we just basically did everything with sectional charts like this, the printed charts. We'd have that out, and we just look outside. Obviously, if you're on instrument flight rules, then you had to use some sort of, you know, navigation like VORs, because they require you to be on airways in there. So, all right, so let's take a look at our, let's see here. Oops. So our Omni bearing selector, our course deviation indicator, that's this device right here. This right here allows us to change our direction, course, and things like that. There's a couple little things that we need to know on here. You can ignore the glide slope flag. That's only if you're coming in for a landing. This flag right here is very important right here when we read this instrument. So first off, let's figure out where we're at. And I don't know honestly where we're at in this sim. So let's bring up a map here. I think we're okay. So there's the Bear-Bedell's Airport, and this is our plane right here. So what I'm going to do, I don't know if you guys at home can see this. I'm going to try to zoom in this a little bit more here. I'm going to turn our aircraft. We're going to change our heading here. Let's see if we can do this. Let's say we're going, I'm just going to turn it to the east here. Okay. So now we know we're north of the Bear-Bedell's Airport. Right here's there's the Bear-Bedell's Airport. There's the VOR station, by the way. And then there's our aircraft heading east. So what we're going to do is we're going to tune in our VOR radio to the Bear-Bedell's VOR right here. And I think I can do this when it's paused. Let's see here. And if you have a Garmin 530, this is basically how you would do it here. So let's go here. All right. Tune this to 117.0. That's the VOR frequency. And you'll notice on your sectionals, you're going to see there's going to be an information block. If you find a VOR station, there's going to be a blue information block in there. It'll say, like, I'm looking at the Seattle sectional right now. I think it says, yes, actually, if you look directly north of the Seattle airport, there's a VOR station. It's the Payne VOR. Here's Seattle right here. And then there's this compass rose up there, that's a VOR there, and it's the pain VOR. It says VOR DME in the block there, and then to the lower left-hand side, it says 110.6. That's the frequency for that VOR. And interestingly enough, there is the Morse code designator for PAE, which is the identifier for that VOR. But you can actually see it's a dot dash dash dot dot dash dot. And to confirm that you're listening to that VOR signal, you'd actually hear that Morse code. So let's see. I don't know if this will simulate it here, but let's. I'm going to tune our VOR. So now we're tuned into the Aeromedical VOR 0.0. And I'm just going to start the simulation now so we can actually see this. And I'm just going to keep the plane. Let me just turn on the autopilot here. Let's see.
Levels of
The Seattle, the airport ID, SIA, I believe. Okay, is Kilo Sierra Echo Alpha. So I've got our autopilot. I'm going to turn that on, and then we'll lock in our altitude, so you don't have to worry about that. All right, so now I'm just going to go ahead and start our simulation. So we're moving this way right here. What I want you to do is focus on this, our Omni bearing selector right here. This is our course. What we call that little white line right there is a needle, and it swings either left or right, depending on if we're left or right of the course that we're on here, or the radial that we're tuned to. So right now, let's go. Let me just turn this a little bit so just to throw it off there. Okay. All right. All right, I'm going to hit P for unpause. All right, there we go. Make sure we're not descending, climbing. Okay, so what I'm going to do, I'm going to tune to this, some radial on here. I want to find out what radial that we're actually on off of the Aeromedical's VOR. We're tuned into the frequency 117.0, which is the frequency for the Aeromedical's VOR. But I want to see what radial we're on. So I'm going to turn this right here. Let's see, I'm just going to turn it this way and watch what happens here as I start getting closer to the radial that we're on. Can anybody guess what that needle's going to do as I move closer to the radial that we're on? You see it move there? Okay, there it's moving. All right. This is now showing right here, if I center that up, that's showing that we are on the 010 radial right there. Notice that this is our flight path. You can see the flight path of the plane there. And notice how this is slowly swinging over to the left. That's because that radial is now behind us. And we're doing a turn. I don't know what happened there. Oh, I must have. Oh, the autopilot just kicked off. Let's get airspeed back up. I think I don't have the sound on, so I wasn't paying attention there. So it's now the plane is turning back, and watch what happens to this as we turn back. It's going to start in a second here. It should start turning back here. Let's actually zoom out here so you can actually see what's going on. So we're actually turning back to east here. Yeah, you can see can everybody see that right there? It's kind of maybe hard to see. There's the plane right there. There's the VOR station. That's pointing true north right there. That is not true north, to magnetic north right there. And our aircraft now is turning to the east. It's almost on an east heading here. So now we are headed east of headed in an eastbound heading, that is, away from the airport. Okay. Now look at our course deviation indicator. That's this little. Oops, I turned that. Let me just move that there. Okay. So if you look at this really carefully, that is slowly moving off to the left. That means each of these little dots here that you see on here is 2 degrees of deflection. So that means right now we're at 2, 4, 6, 8. We're now like on the 2 degree radial. So if I turn this, center this up again. Oh no, I'm sorry, we're on the 18 degree radial. Sorry. So I notice as I turn this to the right, that needle is starting to center again, we read our radial that we're from, that's that flag, that's a to from flag right there. It's hard to read there, but it actually is, can you see it now where it says from there? So that's the from indication. Again, radials are from the VOR. Okay, that's an important point. So if you see this says from, that means the airplane is on the radial, not the reciprocal of it. All right, so let me just pause this a second. Yeah, Donnie, go ahead. What's that? Oh, yeah, not a problem, not a problem. All right, so the one thing that kind of throws people off is if I were to change my direction of the plane here, let's say I change the plane's direction to we'll do north here. Is that going to change this if I unpause the simulation? Is that going to change this needle at all? No, it's not. Okay. Don't get direction of the aircraft, the actual heading of the aircraft, confused with the VOR numbers when you're working with VORs. That's totally independent. All you're doing is you're reading a signal. The aircraft or the radios are reading the signal off of the VOR station. And they're saying you're somewhere on this line right here. That's all it's doing. It's just saying that you're somewhere on that line. In this case, we're reading from, which is a radial. Again, radials are always from the station. We're on, in this case, we're on the roughly 200 or 118 degree radial. I can center this up here. I don't know if it'll actually do it while it's okay. I unpaused it here, and now I'm just going to try to center that needle up again. So now we're actually on the 27 degree radial or something like that. It should stay on that now because we're flying away from the station there. All right. Yeah.
So this would just be basically what direction you want from that station.
Exactly. That's one of the things. But let's say we want to go to Baraboo. All right. So what I would do here is, well, obviously, if I stay in my current heading, oh, the autopilot just kicked off on this again. Oh, goodness. It's doing a turn there. I don't know why. I thought it's
trying to get back to the original course.
Yeah. Let me just do it here. Let's just go to the north here. I just probably have the sound on. It just is annoying there. Okay, there we go. All right, we're good. So now we're turning back to a heading of north. So we're kind of outbound. But let's say we want to navigate to Baraboo. Obviously, if we stay on the heading of 030, that's going to take us away from Baraboo, right? Okay. What heading should we steer to get to Baraboo? To the Baraboo Dells VOR specifically? Roughly. 12 degrees. So let's look at the heading. So our, again, north is, let me just maximize this here. So there we go. There we are. That's north right there. That's 0 degrees or 360 degrees if I go in this direction. South, which is, again, Baraboo's down over here. South is 180 degrees. What direction should I turn? Basically, what heading should I take? Just as a rough estimate, should I take 210, 190, 260? So actually, the answer is about 190 to 200, somewhere in that area there. Okay. So yeah, if you look at this right here, let me just draw the line. This is our north-south line. You can see the lines of latitude and longitude there, north and south, true north and south, that is. And yeah, to get to this, I would have to take a course something like this right there. And if I tune to this reciprocal radial to the station, again, not from the station, I tune it to that station, that radial, or I'm sorry, the reciprocal. That'll take us to the airport. So let's try it once and see if I got it right. All right, so I'm going to turn this right here. We said roughly 210, so I'm just going to keep turning this until we get to roughly 210. Okay, did you notice? Let me just do that again here once. Take a look at this to from flag. I'm going to swing it back here. you see how it just switched from two to two from to two on there? So watch it again here. See how it swings back and forth there, and that flag changes. That indicates whether you're on a reciprocal or a radial on there. So in this case, to the station is the reciprocal. So let's again center it up with two. That flag set to two here. So I go here, and there it is right there. Too fast there. So about there's 190. There's about 200 right there. Okay. So now we're actually on that reciprocal of whatever 30 degrees or whatever 20 some degrees, which is in this case it would be 210 degrees. So we're flying back now. We need to fly back. The problem is the plane is actually still heading north, and we've tuned into the reciprocal, to the station. So in order to fly to the station, we have to turn our heading of the aircraft to 210 degrees or 200, whatever that would be there. So let's do that. So, oops. So I'm tuning that to roughly 210. And let's watch this here. We may have to adjust this a little bit more, but eventually what's going to happen is we'll track this, try to keep this course deviation indicator at 0 here. The one thing that VORs do for you is they automatically allow you to correct for winds. When you're using a VOR, you're basically taking the track to the station, or the correct heading to the station to stay on that center line there. Let's see if I can bring the map up here again. Yeah, we're all over the place here. Yeah, we're doing a turn back there. Okay. So what I'm going to do here is, so now we've got our 210 degree heading in there. I could have just kept on flying outbound on this, at 30 degrees, basically flying outbound, and this would be still showing a center line, or it's showing it centered, but it would be showing to the station, which is again the reciprocal of it, of the radial that we're on. So what I'm going to do now is I want to center this back up again. To do that, I'm going to turn a little bit to here. Let's see if I did that right. So what we're trying to do is we're trying to get this needle centered up, and I did it the wrong way. So right here. So watch this right now as I correct for the course deviation here. You'll see this needle slowly start swinging back into the play here. I did that right. Maybe I had it right the first time. Yeah, I did. So let's see here. Yeah, I did it right the first time. Now, of course, all I'd have to do really to fix this is just adjust my omni bearing selector until I'm on the right radial here, and then track that into the station. Again, there's the 2 flag there. So that 2 flag actually indicates, in this case, the 2 flag indicates that we're on the reciprocal, or actually the reciprocal of, in this case, 15 degrees. So we're on the radial actually would be, we're on the 15 degree radial coming from the station. So let's see it larger so you can see this. The radial is from here. Again, radials are always from the station. Draw this here. So that right there is roughly the 215 degree radial. And that's what we're starting to cross right there. But we've tuned into the reciprocal of that, which is 215 degrees roughly. And we're flying to the station. So it's not, we're actually on the 15 degree radial, but we're tracking to the station. at, 200, what is it? It's 205 degree radial, or, the 205-degree reciprocal, I should say. I know this gets a little confusing. They actually go through it in the book. There are simulations, and I've got links to those simulations where you can learn a little bit more about how VORs work. I'm not doing a great job of describing this, but the one thing that you got to get in your mind is that reciprocal or radials are always they always emit from the station. You have 360 degrees of radials that emit from the station. If you ever get lost and you want to find out where you are in relation to a VOR, you're going to tune this. Like if I wanted to find out what radial I'm on here, I would just tune this right here. Let's get this off here. So let me just put this. Actually, I'm gonna try something. See if you guys can figure this out. So let's clear this and pause the plane here. All right. So I've just moved us to some completely random area. How would I find out where I'm at in relation to that? You guys can kind of see the VOR station there. Let me do this. Yeah. Move it here. Let's go over here and let's just do some crazy stuff here. Okay, there's another VOR station. That's not Beverly Airport. So I'm gonna put our plane right here. Oh, I actually can't see that. Drag this over here. Okay, I'm going to move that right there. All right, how will we know what radial we're on at variably? What would we do? Somebody help me. Yeah, I'm sorry, go ahead. Oh, you can actually see what it looks like. Yeah, it moves really fast. Yeah, it's let me show you here. So I'm just going to drag this. Let's just drag it over here. So yeah, I just, what's this now? I know it's very, very quick. It's All right, so let's try to what do we have to do here to figure out where we're at? So we're lost. We're just looking outside the plane right now, and it's like I don't know where I'm at. How would we find out where? Yeah, Baraboo frequency. If we're near Baraboo, there might be other VORs. If we wanted to, we could tune into another VOR. We'll try that too. All right. So we've tuned that in. We've got 117.0 on the VOR radio there. That's what's that?
On your private settings,
well, we need to know first off what radial we're on, right? So what radial are we on off the Beverly Airport? Yeah, the OBS stands for Omni-Bearing Selector. By the way, that OBS. Yeah, that's right. Not a problem. I just want to make sure you get it. That's right. So, all right. So we want to tune this. Basically, I'm going to turn this until we have a from indication again, because it'll center. If I go all the way around to the other side, it'll center with a 2 indication there. Watch this. There's a 2 indication. Let me take this over to the right here. Too far. There we go. That's our from. Let's. Here we go. Okay, that centers up on 2, but we're definitely not on the 390-degree radial because we're south of Baraboo. I know that because you guys probably saw it when I dragged the plane down. I dragged it down, well below Baraboo there. So we know we're not on the north side. That's because again we're on the reciprocal of in this case, the reciprocal of 350 is roughly 170. All right. So to correct that, all I'm going to do is just take this and there's our from. Oops. That's all right. So we're reading from that. This right here is the radial that we're on. So we are south of the airport. Let's bring up the map here so we can actually see it here. So there's our plane, And let's see if we can find the Baraboodel's VOR here. Yep. Okay. So here's, it's kind of hard to see. Again, for the people at home, they're going to have a tough time seeing this, but there's the VOR station right there. There's our plane. We're south of the field. And that makes sense. We're 200 or 170-degree radial from the Baraboodel's VOR. There it is right there. And that makes sense, right? It's 170 degrees from it. So that's how you would do it. That would tell you where you're at. But let's say we want, that only tells us that we're somewhere on this line. What if we want to figure out, well, where are we on this line? So we can see there's a VOR station at Janesville. There's one at Madison. Well, if we know we're in the Madison area, I would just tune to that. So let's zoom in here and see what the Madison frequency is. Let's see. Oh yeah, I'll do that in a second. That's fine. Yeah, that's on. Let's see. Section. Sure. I'm not seeing the information block for that. I should know what that. Oh, here we go. 108.6. Yeah. Okay, that's the Madison VORTAC. So I click on that. Okay, so now we're tuned into the Madison VORTAC, and now all we have to do is find out the from radial from Madison to find out where we are in that line. So basically, I'm going to click on this. Is it this right here? Is this right? You guys tell me. What radial is that? Well, actually, let me just check and see if it's off the radials there. Yeah, we're only this. It does not look right. Okay, so what am I doing wrong here? Because this is not the radial that we're on in Madison. So if you look at the flag here, it's saying 2. I want the radial, not the station. I want the radial from the station. So I'm going to turn this until we get to from indication and center that needle up there. There we go. All right. So now we can read the radial. In this case, it's 105 degrees. It still doesn't seem quite right. Let's just see. There's something wrong there. Yeah. Oh no, that actually is about right. Yeah. There's the plane right there. There's Madison. We're on the 195 degree radial, 96 maybe degree radial from Madison. And then the Baraboodel's VOR is right here. So we kind of know we're somewhere on this line. If I tune into Janesville, that's going to give us a radial of what? Does anybody want to take a guess what the radial out of Janesville's VOR? This right here is the Janesville VOR. Yeah, about 260, 270, somewhere in there. Yeah. Okay, that's the radial you'd have if your flag indicator right here was indicating from, right? If you're indicating 2, then it's going to show on the top there. So the way to understand this, if you can, with VORs, and again, you want to read on this to understand a little bit more. But you've got when you've got a from indication, the reciprocal always shows, regardless of what you have up here, the reciprocal of this up here is always down here. You see, you've got a little white or a little yellow indicator there, and you've got a yellow indicator here. They are, again, just opposites, 180-degree opposite each other there. Okay. So if you've got a from indication, then in this case, we're on the 196-degree radial from Madison, roughly. Tune this more there. We're now 195-degree radial from the station. But if we wanted to turn around and go back to Madison, we'd tune in to this one right here. This is 15 degrees. So let's say if I want to go to Madison, I would just tune this in until the flag reaches. Watch here, we're going to hit the where it crosses over. It's going to switch here in a second. Oh, wait a minute. I didn't see that switch over. Did you guys see that switch? That's like, but it did. Okay. All right. Right. So there's our center needle right there. And now if I turn the aircraft to match that heading right there, that's saying that reciprocal there, this is now it becomes the radial. And so we're actually on the 195-degree radial there to go to the station. We're flying the reciprocal of that, and that's going to be 115. So if we go here, we're still flying south. I want to turn to navigate to 115 here. So I want to change my heading bug to 15. Oops, too far. Right. And then that'll cause us to get on a track to go to Madison. Yeah. Okay, not a problem, not a problem. And you know something, at this point, you guys, we've pretty much covered everything. If you want to, we can walk over or go over the aeromedical stuff. But again, most of that stuff is just basic reading, so I don't really need, I wanted to spend some time on the navigation portion of it, E6B and stuff like that. Do you guys have any questions? I know there's going to be a ton of questions you have. I guess the big thing for you now is to take those quizzes that are in the portals. If you have trouble with some of the questions, just know that I'm not always right on the answers on those things. So if you get something wrong, it doesn't necessarily mean you've got it wrong. It may mean that I went through like 600 questions. I had to come up with on that. So it's I know I made mistakes on it. So if you do have trouble with some questions, at least email me. If you want, I can meet with you. We can go over things. And then at some point, the next couple of weeks, if you want to schedule time, we'll go ahead and first off, we got to take you up for a flight. Everybody here obviously gets a flight. If you want, what I can do is I can schedule individual flights in the 150, which we could actually log. You'll actually get loggable flight time in that, training time in the 150. Then it's just basically you and me. There's only 2 people in the plane. The twin Comanche, I can take 3 other people in it. We've got some other pilots that'll take students up as well if you want to fly in a plane. But we have to kind of schedule it out, and I have to coordinate with other pilots there. I'm hoping we could just schedule a day for it, but at this point, we'll do individual flights, and we'll see if we can come up. If I can choose a day that works well, we might do that. And then if you just can't make that date, don't worry about it. We'll just get scheduled, and we'll do your flight then. The other thing that we have to do is, and you'll be getting an email from me this next week, from SIA anyway, about your next steps, what you have to do if you want to continue on with this. So what you're going to want to do is complete the course, read through all the rest of the materials. If there's areas that you're deficient in, everybody, by the way, if you're honest with yourself, I was deficient in all kinds of areas. Weather theory, I had problems with. I had really problems with pressure, altitude, and understanding all that stuff. And I had to sit down with an instructor again and just kind of go over that again. It's not like you have to know this stuff inside and out, but you have to know it enough so that you can, take the test and do a fairly decent job, when you take it. If you take the practice test, which we do have links to on the SIA site, there's I think King Schools has a practice test. If you actually take that test, write down the areas that you're deficient in, and then talk to me about it. We'll get together. What I have to do then is determine, okay, are you ready to take the test? If you are, I'm going to sign you off, and then you'll schedule your exam down at Middleton, down there. And I think it's like $150 for the actual exam. So you want to make sure that you're ready to take the exam. If you have financial issues or something like that, and you can't afford that, get a hold of me and we'll work something out. But for the most part, if you'll get it scheduled, I'll sign you off. You'll also, in that process, I'm going to set you up so you get your FAA card that says you're a student pilot, and then you'll be able to show that to other instructors or fellow friends or whatever, anybody to let them know that you're a student pilot on there, and you've gone through some of the training and stuff like that. And then at that point, it's just a matter of scheduling training with a flight instructor and getting it. The rest actually is easy. You guys have done the hard part in this class. The knowledge portion, nobody likes. It's just like when you're in the plane, you're going to be so far ahead of most students because you have this knowledge that you've already learned. And your instructor is not going to have to tell you this stuff again and again and again. You're already going to know this. And so your flight time, normally it takes about 40 hours to get your pilot's license. And I shouldn't say normally, that's the bare minimum that the FAA requires that you take to get your pilot's license. The vast majority of students are in the 70, 80, 90, and some are even in the hundreds of hours. You guys, I'm almost positive, are all going to be in the low 60s and 40s, depending on how much time you can get, flying. So, but you're out of the gate, you have knowledge that the vast majority of people don't have when they go into getting their doing their flight lessons. And so you're just going to understand this. You know what happens when you pull back on the control wheel. I'm surprised to this day how we do these simulators we donate to schools, and I've had people grab the yoke because they don't know anything about aviation, right? So they grab the yoke and they try to twist it like this to get it to climb or descend. And so what you guys know, you guys would be great additions to our staff if you guys could go to these schools and show students how to fly planes. You already know that stuff, and you can apply it, in teaching others. So, but you understand the physics of flight. You know how stalls work, so you can explain to students, how stalls work. And I would definitely, and speaking of that, when you're talking, sharing with your friends, try to teach them a little bit about what you've learned. That also helps you cement those concepts in your brain. You'll be able to explain it to them. If you don't understand something, you can always ask me or ask another pilot or something like that, just so that you've got it down. But if you've got a SIA sim at your school, definitely help the students out, because you guys have now have a lot of knowledge on this, and you've managed to put up with me talking about this for countless hours. All right, any questions at all? All right, so I'm going to be here next week. I'll be at the SIA in the SIA office there. So you'll probably need a gate code. I'll probably provide that on the email. I got to talk to the airport manager here and just find out if he wants me to do that. If push comes to shove, I may have them. Maybe they'll temporarily open up the gate for you guys so you can just drive in. Does everybody know where my hangar is? The SIA hangar is. It's okay. I'll send directions on there. Basically, you instead of going to the FBO parking lot, you're actually going to turn and go through a gate. When you come in, you'll take a right, you'll go through that gate, and you go down to 3rd Street and then take a left. And we've got a big hangar down there that we can meet at there. So, all right. You guys have been fantastic, by the way. I've really enjoyed working with you, and I'm sorry some of this stuff is. It's not fun, but like I said, you guys have done really well with it. And if you have questions in the future, you can always reach out to me. This is just the start of it. So, all right, yeah.
You did say something. You did said something good to staff. How do you have to be the staff?
We don't really have any, restrictions on ages and stuff like that. So it's a volunteer position, because we're all volunteers. Inside we don't pay anybody to do stuff. So, but if one of the things you can do, what school do you go to? Homeschool. Okay, yeah. So, you could consider maybe going to, like some of the, Kelch Aviation Museum is a good one. We'll probably have other museums and stuff like that. And if you can get into some of the schools, you can actually teach some of the students how the sim works. The best thing to do would be to meet with me. I'll show you all the ins and outs of the sim. And then that way you can kind of practice it, a little bit. We do need people to test the sims before we ship them out,
We live
a mile down the road, like 2 miles from the.
Yeah.
He is talking about this summer. Dad, can I ride my bike to the airport and do something?
Yeah, and that would be something we can work out. So we've got to, let's stay in touch on email. You got my email. The best way to get a hold of me is definitely by email. And then there's
Because he is, just turned 13, so he can't get his pilot.
yeah.
Would be in your possibly next year if it's around.
Yeah. It's my guess is it's going to be up in Boston. We'll probably have another person that will be teaching, so I can't. We're so busy now I'm writing the curriculum for the sim now, and it's a lot of work. And then I'm also building the sim. So, but if we can get him in there, maybe we can have him, if he's good with computers, maybe he can help us build some of them and test them out. So that would be really helpful. So, but yeah, let's stay in touch.
Yeah,
Yeah, fantastic. It's been great having you guys here.
Did you just go to
May.
Are you guys?
It's my Actually, can't point out
that your lift is gonna be efficient compared to your weight.
I do not have to do this. I don't know. Actually, I don't know.
Most likely, just in our schools, I do not know because we homeschool. So, yeah, so I don't know. Okay.
More stuff like that.
Just so that we can visualize them, it's visual aids in that. It's very cool. And what kind of printer are you using? Okay. Yeah. But an M3 get you doing it and filing and very cool. Very cool. So when you're printing one that you can put a butter in. It's awesome. Where are you based out of?
I'm in
So
45 minutes.
okay. I think we're still. Yeah. I'm not, so Theo wants to go, we're talking about getting a 3D printer here this fall. Sorry. Yeah. STL file? STL. So I can. See, that's a skill. So many skills I want to learn. What programmers?
Yeah, it's called on shape.
Okay. That's the one you use, right? Grow up is the one you use.
I find
Yeah, yeah. It's fairmarker at mail.com. So BA. Yeah, it's Chinese. Yeah, exactly. So, when you get the email back, spend the time on make sure you get these students or any cards. And there's like
I can take back, it's like one back.
yeah,
We'll do the meeting and then at the meeting we'll talk. So we have two.
Three for maybe just like stuff. That's the old Andrew and.
Yeah, next Saturday. So I'll be at the.
Yeah, we need to get a plotter.
Thanks. Yeah, not a problem.
And we have one of these.
Oh, you guys didn't have one, did you? Yeah, go ahead and take that. Yeah.
That way we can play and.
Yeah.
And practice.
Spotlights.
Zach. Without going through bombing.
I imagine. Can't spin the as far as
Right,
So-
there's a certain
Very
volume.
much.
But I would imagine Madison's reaches.
No, actually, Fairview reaches much farther. Fairview is what we call a high volume work area. So, you get up to, so I didn't talk about, the city didn't talk about the curvature of the air dictates, how far the signals they go. That's true. It's, if there's terrain around it, so so if you're down below, let's say these are VOR, here, and there's a block right here, obviously you're not gonna go on the other side of that block. However, if you get up there, your house far, you'll have no problem 30 miles, 40 miles. And when you get up to like, it's like 10,000, 20,000 feet, it actually sends out very much 120 miles. Which you never don't see. They actually, all the airplane pilots are used the Aeromedical bells. So if you look on a plane there, you'll see planes all the time. Of course, they're way up. Because they're going across, they cross the. Yeah. Yeah, it does depend on your altitude, right? Yeah. It's, basically mine. So, and they do have a certain, they call it service volume, I guess. So, again, they go over the order. Yeah.
Exact number, but the Mach number is 2 miles just over 2, but that's on a completely barren. It's like no external fuel tanks.
So we'll see.
That's like it's roughly like 1,000 insulated.
When they first built the big service, possibly. So it's stuck in my head that there were some. I don't know what. Maybe I'm looking at another jet or something like that. Gotta unlearn that. Like, for some reason, this was stuck in the sunset.
They don't usually get to go that fast.
Yeah, but this is really funny. I visit where the military operations.
That's my dad.
He goes up there. Yeah, it's but every now and then. Well, I was up there one time. I don't know. No, just doing this like there's flying out. Really? Yeah, they were breaking the songs. They like the vast. They said they're so used to it.
Yeah, my dad had a small town directly in the middle of the MLA.
Yeah.
So they would always like your fly over.
Oh, so cool. I would love that if my sister has her actually lives in I think he was an F-16 pilot, and when he was in the Air Guard, he would he'd occasionally play. And there was one time I was there, and he said, "Oh, yeah, you can see this." And I turned up. That's just the coolest thing.
Yeah.
Yeah, that would be nice. All right, Ethan. Yeah, we'll be in touch then, sir. You take care.